Hello my dears, how are you all? So in the last class we discussed about the concept of filters, right? What are the important types of filters and what its peculiarities, specialities, or we discussed more detail about the all pass filter, right? All pass filter, that's very important, and we did some important conclusion from that all pass filter. That means its magnitude or its gain is 1/2, that means it's a constant, or its phase angle will be vary from 0 to -180. It's very important concept, all pass filter, regarding all pass filter. So that's all about those filtering section. Next we have to see a very important session in circuit theory, that is nothing but coupled circuit. That is nothing but coupled circuit. Coupled circuit. It's very important in electrical engineering. Okay, coupled circuit. So coupled circuit. So what is the meaning of coupling of two circuits? The meaning of coupling of two circuits is that if two circuits are said to be coupled, then it shares some common flux between them. That is the meaning of coupling. For example, in a transformer, the transformer is said to be electrically isolated but magnetically coupled. The meaning of magnetically coupled is that a portion of the primary flux is linked with the secondary winding. A portion of the secondary flux is also linked with the primary winding. That means there is a mutual coupling of fluxes, right? The coupling circuit means coupling of fluxes, right? That is the meaning of coupling. So let's see a basic coupled circuit, and we have to derive some very important relations from that. Okay. V2 of t, and it will be I1 of t, and okay. So consider a circuit. Simply two coils are there, and which is placed nearby like this, and V1 of t is the voltage applied across the first coil having an inductance L1, and V2 of t is the voltage applied across the second coil having inductance L2. I1 of t and I2 of t respectively the currents across each coil, and M is nothing but the mutual inductance between the coils. Mutual inductance means nothing but it is a relationship, you know that mutual inductance M is equal to what? K root of L1 L2. This is nothing but the mutual inductance. That means common inductance, in simple words it's the common, or it is nothing but K root of L1 L2, K root of L1 L2. Or we can say that how much inductance is common to both primary and secondary. That is the meaning of, the simple meaning of what? Mutual inductance. Okay. So we have to see that we can say that V1 of t minus L1 into di1 of t divided by dt minus M into di2 of t divided by dt equal to 0. Can I say like this? That means the input voltage we applied actually minus or equal to L1 into di1 divided by dt, that is nothing but the voltage developed across this inductor L1, and due to this current I2 beta, due to this current I2, there is also some flux generated, right? Due to this current I2, due to the voltage V2, there is a current I2 of t. Due to this I2 of t, there is a flux surrounding this inductor L2, inductors L2. So that flux also, a portion of that flux also linked with L1, right? A portion of that flux also linked with L1. So that the effective flux linkage across L1 will be nothing but the flux linkage due to its own current plus the flux linkage due to the neighboring current. The flux linkage in the total flux linkage in the L1 or the first coil is that it is a flux linkage due to its own current. Whenever this I1 is flowing through this, there is a magnetic field associated with the conductor. If this I1 of t is changing with respect to time, then this magnetic flux also changing. If this coil L1 is situating in a time varying magnetic field, what happened? Due to Faraday's laws of electromagnetic induction, there will be some induced EMF. That induced EMF is nothing but L1 into dI1 divided by dt. Correct? L1 into dI1 divided by dt. Or what is the meaning of minus sign? That is always opposite to the applied voltage. That is why it is minus L1. And not only that flux induces EMF in the coil L1, but the current, due to the current I2 or T, there is a flux in the L2. A portion of that flux also linked with L1. That flux, due to that flux also, there is an induced EMF. That is nothing but M into dI2 of dt. Why this I1 of t here and I2 of here means the reason for this current is I2 of t and not it is exactly L. Even though the unit of L and M are same, it is nothing but Henry. In primary circuit is L1, but due to the second coil on primary coil, we seek the help of what? Mutual inductance M. Mutual inductance means the inductance mutual for first and second coil. That is M into dI2 divided by dt. Similarly, we can say with respect to V2 also, V2 of t minus L2 into dI2 of t divided by dt minus M into dI1 of t divided by dt equal to 0. This also you can say the same manner. This also you can say in the same manner. So the equation regarding V1 of t and V2 of t you have to note. You have the capability to derive the equation. If simply give some value of two circuits like this, you have to write the equation current corresponding to that what L1 and L2. That is why I did the equation. Okay, and if this is like in this coupled circuit analysis, there are two dots always you can see. The meaning of this dot is that the point at which current entering, is called the dot. So here the dot means this region current is entering. Here the dot means this region current is entering to the circuit. And if some other circuit is given to you, in which say suppose this is the dot here and this is the dot here. Then what will be the change in this equation? Regarding this same manner, this L1 and L2 remaining all will be same, V1 of t and this is I1 of t, and similarly it is V2 of t and this is I2 of t, right? This is I2 of t. This is I2, this is minus, this is plus. This will be the diagram. If the dot is changed from this diagram to that diagram, what will be the change in equation we have to see? With respect to this V1 of side, V1 of t minus L into L1 into dI1 of t divided by dt plus M into dI2 of t divided by dt. That is the difference. If dot is changed means the equation for M is also changed. The sign of M also changed. And similar to that V2 of t minus L2 into dI2 of t divided by dt plus m into di1 of t divided by t equal to 0. That is the change. That is the change. That is a change happened. Clear? So you have to write, if some circuit is given and write the voltage equation for that, means you have to think and write like this. You have to think and write like this. Otherwise the problem, doing some problem, so it may be useful, doing some problem. This KVL equation is very, very important. That's why I wrote this equation. Okay. Next we have to see series connection of inductors. It's very, very important. Series connection of inductors. Series connection of inductors. Draw this circuit diagram. Yes, draw this figure. Draw this figure. Draw this figure. How can we write the voltage equation for V1 of t first? V1 of t first. I can write like V1 of t minus L1 into di of t divided by dt minus m into di of t divided by dt equal to 0. Can I write like this? Simple voltage equation regarding this V1 of t. That means, what are the components of V1 of t? V1 of t minus or V1 of t comprises of, from this equation you can write like V1 of t will be equal to, what is that? V1 of t will be equal to L1 di of t divided by dt plus m into di of t divided by dt. Or we can say that this V1 is comprising of L1 into di of t plus the mutual inductance due to the induced EMF due to the mutual entrance, that is nothing but m into di of t divided by dt plus. It is nothing but, it is the inductance, this is the EMF due to its own inductance, that is this term. It is the EMF induced due to mutual entrance, that is this term. So that is the voltage across, total voltage across V1 of t. Similarly, that will be equation number 1. What will be V2 of t? What will be V2 of t? V2 of t will be equal to L2 into di of t divided by dt plus m into di of t divided by dt. Is it correct? This is equation number 2. That will be equation number 2. If you add 1 and 2, we will have V of t will be equal to V1 of t plus V2 of t equal to, what is that? L1 plus L2 into plus L1 plus L2 plus 2m whole bracket di of t divided by dt. Correct or wrong? Correct or wrong? This L1 plus L2 plus 2m is called the L equivalent, or L equivalent equal to L1 plus L2 plus 2m plus 2m. So this circuit is called series aiding. Series aiding, or this is for what? Series aiding. Series aiding. And if, that means in the circuit the current is entering at both in the same side, right? here also in this session, here also in this session. Suppose the circuit is in such a manner that you are supposed to arrange the current in this direction such that this current is enter from here. This current is enter from here is called the series opposing. Series opposing means see the circuit. Same circuit. This is the difference. Series opposing circuit means the current entering in one coil is in one direction and the current entering at the other coil is in opposite direction. So what will be the change in this value means it simply L equivalent will be equal to L1 plus L2 minus 2M. That is the only difference. That is the only difference. It's a very, very important relation. Series aiding circuit, the L equivalent will be equal to, that is the total inductance will be equal to. You don't want to derive all this equation in examination. You just need this equation for solving problem. Problems are very, very important, not derivations. This derivation is for your understanding, not for examination. Okay. And if the circuit is series aiding means what? The flux produced in one coil aiding the flux produced due to other coil. That means the total flux in the circuit will be equal to the sum of the flux produced by this plus this. That means in the same direction. There will be addition of fluxes in series aiding circuit. But in the case of series opposing circuit, what is the difference in series opposing circuit means the flux produced in one circuit is opposes the flux produced in other circuit. That means the two fluxes are in opposite direction in series opposing circuit. So the net flux here will be less than that of that circuit. That is why it is called a series opposing. If the net flux reduced means the net EMF, net EMF also reduced and L equivalence also reduced. So the L equivalent here is L1 plus L2 plus 2M for series aiding, and for series opposing L equivalent will be equal to L1 plus L2 minus 2M. In the same manner you can derive this also, but derivation is not part of it's not a cup of tea for us. It is simply we need this equation L equal to L1 plus L2 plus 2M for one circuit and L1 plus L2 minus 2M for other circuit bus. That's all. Okay. So that is the concept of series connection. That is the concept of series connection. I think it's very clear to you. In this session, the problems are very, very important. Not the derivation side or the equation side. No. The problems are very, very important here. So you have to do the problems. Okay. And next we have to see a problem, a simple problem, so that you can get the idea. Find the L equivalent. Find the L equivalent in the circuit. How can we find? How can we find in the circuit? See, if you see the circuit, the current entering in here it is in the position, and current entering the second circuit is in this position. That means the current entering in the two coils are in same manner. So this is a circuit, or this is an example of what? Series aiding circuit. This is an example of what? Series aiding circuit. So for that series aiding circuit, what is the equation? L equivalent will be equal to L1 plus L2 plus 2M. L equivalent will be equal to L1 plus L2 plus 2M. Or what is L1 here? 2 plus 6 plus 2 into 3. M is nothing but 3 Henry. So 2 plus 6 plus 6, it It is 14 Henry. So that is the answer. That is the answer. Bas. That is the answer. Is it clear? It's very easy actually. It's very easy. You don't want to confuse, right? You don't want to confuse at all because it's very easy. You just know the concept here, okay? Just know the concept and just the equation. Bas. For examination point of it's more than enough. It's more than enough. Okay? So that's all about that problem. Let's do one more interesting problem from the same session. Write a question. Write a question. Find L equivalent. Find L equivalent. How can we find? How can we find L equivalent here? How can we find L equivalent here? So here the difference from the first problem is that here it contains 3 circuits, right? 3 circuits or 3 coils having 3 inductance, and respectively the self inductance are given and mutual inductance also are given. 5 is nothing but the inductance between this and this, mutual inductance between this and this. 2 is nothing but the mutual inductance between this and this, and 1 Henry is nothing but the mutual inductance between this and this. We have to correctly apply the equation. That is our aim here. So according to the equation, L equivalent will be equal to L1 plus L2. If there are 3 inductances, this is nothing but L3 plus 2M1 plus 2M2 plus 2M3. If the all circuit is series AD, this will be the equation. If some circuit are series opposing, means only change will happen in the equations of M1 and M2 and M3. No change in this L1 and L2, L3, because whenever the self inductance are either in series aiding or series in opposing, the self inductance will be simply added together, but the mutual inductance will be added or subtracted. That means plus or minus depending upon the nature of the flux that is flowing through the circuit. That we have to take care. Okay. In this circuit, plus 2M1 I can write, because in this here also this is the dot, here this is the dot. In same manner, in both the circuit 2 Henry and 3 Henry, the current is flowing, so that it will be plus 2M1, and in M2 and in M1 and M2, like M1 and M2 also, how can we write like this? In the circuit this is the direction, but it is opposite. So in between M1 and M2 there will be minus 2M2. There will be minus 2M2, and minus 2M2, and in between 1 and 3, in between 1 and 3 also it is opposite, so it will be minus 2M3. This will be the total L equivalent in the circuit. This will be the total L equivalent in the circuit. Total L equivalent in the circuit. Okay, this will be the total L equivalent in the circuit. L1 plus L2 plus L3 plus 2M, because in this circuit this is plus and this is also in same direction, right? In this manner the current is entering, this manner the current is entering, so plus 2M1. But with respect to 1, 2 and 3 it is opposite, that is why 2M2. With respect to 1 and 3 also it is opposite in nature, so it will be 2M3. Substitute the values, corresponding values here. You will have, what is L1 here? It is 2 plus 3 plus 4, right? 2 plus 3 plus 4 plus 2 into what is M1 here? M1 is nothing but 5, right? 5 minus 2 into M2 is nothing but 2 minus 2 into m3 is nothing but what beta? 1. So the resultant will be 2 plus 3 plus 4 is nothing but 9. L equal will be equal to 9 plus 5. So 9 plus 10, right? 9 plus 10 minus 4 minus 2. It will be 90 minus 6 will be 13 Henry. So that is the answer. That is the answer. Not the answer. Please note the answer. Okay. The Kepler circuit is very interesting actually. If you do more and more problem, you will feel the interest. You will definitely feel the interest, right? So that is all about that problem. That's all about that problem. And next we have to see parallel connection. Parallel connection. So in the previous session we discussed about the series connection of two inductors, whether it be in series aiding or series opposing. Similar manner, there is parallel connection of inductors. I of t. So in this connection, parallel connection, we can write like V of t minus L1 into di1 of t divided by dt minus m into di2 of t divided by dt equal to 0. This is regarding to V of t regarding to one equation, and in other equation also there is one more equation regarding V of t. V of t minus L2 into di2 of divided by dt minus m into di1 of t divided by dt equal to 0. So there are two equations regarding V of t in this equation, I mean in this circuit. One is for, see, regarding this L1, or when I am focusing only on L1, what will be? It will be V of t minus L1 into di1 of t divided by dt. Correct or right? Correct. Because due to I1 of t there is an induced EMF in the L1, that is this, and due to the neighboring flux also, due to the flux due to neighboring inductance also, there is an EMF. That is nothing but m into di2 of t divided by dt. That current is nothing but, that flux is due to the second current, right? That is why minus m into di2 of t divided by dt. Both are in same direction now. In this direction, here also dot, here is the dot. So it will be minus always. And again V of t can also be write in terms of L2 into di2 of t minus m into di1 of t divided by dt equal to 0. Same manner, right? The same manner regarding to first focusing on L1 and consider the mutual inductance of second one. Next voltage, consider a second and mutual due to first coil. That is the equation. If you solve this equation 4, we can say that L equivalent is nothing but L1 plus L2 plus or minus 2m in case of series aiding, plus or minus, I mean plus aiding for series aiding, and minus 2m for series opposing. Like that. In this equation, I mean this parallel connection also, there is an equation for L equivalent, which is nothing but L1 L2 minus m square whole divided by L1 plus L2 minus plus 2m minus plus 2m. Here minus for same behavior and plus for opposite behavior. Minus for same behavior and plus for opposite behavior. Opposite to that of series connection, right? There L1 plus L2 plus 2m for series aiding, right? Same behavior, right? But here in denominator minus for same behavior and plus for opposite behavior. That is why minus plus 2m. That is why minus plus 2m. Is it clear? Is it clear? Is it clear? So you just need this equation, right? You don't need that derivation side and all, how it obtained, and we don't need that. We just need that equation L1 L2 minus m square divided by L1 plus L2 minus or plus 2m, the bus. That's only we need. That's only we need. Okay? Is it clear? Is it clear? And next is T network conversions. This is also very important. T network conversion. Okay. And M is the mutual inductance. This same circuit can be represented like, or this is equivalent to, this is equivalent to, this is equivalent to L1 minus M and L2 minus M and minus. That means, and which is again equivalent to, listen, these are some conversion techniques. These are conversion techniques. Where it is used means, it is used where some problems are given to you and we have to find an easy way. Then this conversion process is very helpful. Like, suppose so many resistors are given to you in star or delta connection. No, it is very easy for using some star or delta format and solving, right? That is very easy, right? Similar manner, if this is the circuit here, if you want to find something in the circuit, if two circuits are magnetically coupled but electrically isolated means, it is very difficult. It is very difficult and complicated. But if the two circuits are electrically as well as magnetically connected, electrically as well as magnetic coupled means, it will somewhat easy for solution of the circuit, or for winning some parameter of the circuit. How can it will be solved means, we will discuss in next 2-3 problems that we will discuss. Okay, so the circuit can be converted into the circuit. The inductance value will be L1 minus M, L2 minus M and M, or in other words, if L1 plus M and minus M and L2 plus M, or in other words, these both are same. Okay, we will do the concept with respect to a problem, then it will be very clear, very clear. Okay, so write a problem, you will get an idea. you will get an idea where it can be used. These are the dots. How can we find its T equivalent network? How can we find its T equivalent network? What will be the T equivalent network? Definitely it will be in the format of like this, right? Definitely it will be in the format of like this, because it is the form of T. There will be of course V1 and there will be of course V2. What are the inductance values? What are the inductance values? See, there are two inductance are same manner, right? Seriously connected. Then effective inductance will be L1 plus L2 plus 2M. That will be the effective inductance if you consider for a single circuit. If you consider for a single circuit, right? But there are two circuits, right? First is this and second is this, right? So that equation is not applicable here. There you can apply this equation. There you can use this conversion technique. Did you get where it can be used? If it is this circuit means you can simply apply L1 plus L2 plus 2M here. Easily you will get the answer. Correct? But if this is the nature of the circuit means you can't apply the basic equation for series or basic equation for parallel, whether L1 L2 minus M square divided by L1 plus L2 minus or plus 2M or L1 plus L2 plus or minus 2M. Those two equations, no, those three equations we can't apply here, because it's neither in the series circuit or nor in the parallel connection. It's somewhat a different manner. So in order to solve for this type of circuit, we need the help of T conversion. So that conversion will be equal to, this will be equal to what? Simply 2 L1 inductors are series, right? So the effective inductance will be nothing but, effective inductance will be 3 plus 4 minus 2. Simply 2 minus 2. L1 plus L2 minus M. This will be equal to what? L1 plus L2 minus M. If one circuit means it is simply one inductance means it is simply L1 minus M. If two inductors are there and both are in series, right? Both are in series aiding nature, then inductance will be, I already told you that inductance will be always added. Always added. If n number of inductance are there, then n will be added together. There will not be minus there. There will not be any minus because L1, L2, L3 will be added. But M, in considering the case of M only, there will be what? Sign changes. Consider in the cases of M only, there will be what? Sign changes. Well, we want to bother only regarding M, not regarding that L. That is the main concept here. So it will be L1 plus L2 minus M, and here it is simply M, right? So here it is 2, and here also simply L2 plus M, right? So L2 minus M, right? So it will be 5 minus M is nothing but 2. So that is the what? T network, equivalent network. So it will be simply what? It will be simply equal to, it will be equal to what? 3 plus 4 is 7 minus 2, it is nothing but 5. So 5 Henry, 2 Henry and 3 Henry. So that will be the answer. That will be the T conversion. That will be the T conversion. Okay? Is it clear? Is it clear? So these are actually your, I think you didn't study this in BTech electrical, right? BTech electrical. These are advanced topic. These are actually advanced topic. Okay. Normally you have a problem maximum at the range of L1 plus L2 plus 2M, L1 plus L2 minus 2M, or maximum in the case of parallel circuit, not the combination like this. No, these all are advanced level. If the questions, for our unlucky, or for our unluck, if the question paper is very difficult, then you may expect this type of question there. You may expect this type of questions there. That is the reason why I am doing these problems, right? I am doing these problems. Okay. So let's do a wonderful question now. See, questions are very, very important. Through the questions we are learning so many things. Through the questions we are learning so many things. All theory, everything. We are learning through what? Theory. We are learning through theories. Problems. Okay, write a beautiful question. Write a beautiful question. Find L equivalent between, right? L equivalent between 1 and 2 is 4 Henry when 3 and 4 open circuited. L equivalent between 1 and 2 is 3 Henry when 3 and 4 short circuited. Determine coupling coefficient. Determine the coupling coefficient. Write the question. 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 How can we proceed with? How can we proceed with such a question? This is very, very important question in this whole class. This is very, very important question in this whole class. How can we proceed with? How can we solve this? See how standard the question is. How standard the question is. This all will be asked in the range of gate level examination, no? But we have to prepare for that also. If the examiner is tricky, the examiner is too brilliant, right? Not examiner, but the question paper is very hard, right? All the person who are preparing the question paper are brilliant, of course, there is no doubt in that. So how can we start with actually? Can we do the question directly from the circuit? This circuit, can we do this? No, you can't do this. Because it's electrically isolated circuit. For electrically isolated circuit, we can't consider for open circuit, we can't consider for short circuit because it's already electrically isolated. Only for electrically coupled circuit we can consider for short circuiting and open circuiting in easy manner. There is open circuit and CT circuit or short circuited for electrically isolated also, but as far as our concern, that is nothing but the inductance concern, it is very easy if you are solving the circuit in electrically connected manner, not in electrically separated or isolated manner. So what is the way to connect the circuit into electrically connected manner? This is electrically isolated, this is magnetically coupled and electrically isolated. We can't directly proceed with this electrically isolated circuit, but we can do something with, if the circuit is electrically coupled, what is the purpose or what is the idea? What is the idea, or what is the conversion that we can use here? What is the conversion? It is T conversion that we studied in the previous session. T network conversion that we can use. How can we use that? How can we convert this into equivalent T network, which is nothing but see, clear? So this is terminal 1, this is 2, and this is 3, and this is 4. Is it clear? So this is nothing but L1 plus M, correct? This is M, and this is nothing but L1 minus M, right? And this is nothing but L2 minus M. L2 minus M. Correct? So this is the equivalent of this figure. This is the equivalent of this figure. Okay? So case 1. Let us discuss first case 1. Case 1. What is case 1 here? What is case 1 here? L equal to between 1 and 2 is 4 Henry when 3 and 4 open circuited. That means in this figure, listen my dears, very very carefully listen. So this is nothing but L1 minus M, this is M, and this is M. 1 and 2, 3 and 4. In this figure, it is given in case 1 that L equal between 1 and 2 is 4 Henry when 3 and 4 is open circuited. If 3 and 4 is open circuited means there is no inclusion of what? There is no, not at all, there is no importance of this L2 minus M here because it is open circuit or simply it's in air. It's in air, not it is connected to the terminals. It is simply in air. So these can be simply omitted. This can be simply omitted, right? This can be simply omitted. We don't want to use that circuit. L2 minus M, it's not existing because it is open circuited simply in air. Simply in air. So the effective inductance will be simply nothing but the series combination of simply nothing but L1 minus M plus M. Because M also a type of inductance, right? M also a type of inductance, right? And see, this is the current direction here and same direction here also. Same direction here also. The total inductance in the circuit will be, this plus this series circuit, right? It is series circuit, right? It is series circuit, right? That's why it is L1 minus M plus M. L1 minus M plus M. You may have a doubt in your mind that due to the flux in the M, this circuit also there is an inclusion of flux in the first coil and we can't use this equation, sir. We can only L1 plus L2 plus 2M here. L1 plus L2 plus 2M you can use here directly, right? You can have a doubt that if you convert this first inductor like L1 minus M and second inductor like M, the effect is equal. It is equal to L1 plus L2 plus 2M in series aiding circuit. If you convert the inductance into L1 minus M and M, it is same. It is same. Clear? So the L equivalent is given, M and M cancel, nothing but L1 is equal to, L equivalent is given in the question, right? It is 4 Henry. So that is the case 1. So from the case 1 you got the value of L1 equal to 4 Henry. Let me check the time. Okay, time is there. So L1 equal to 4 Henry. And let's discuss case 2. What is case 2 here? See, in the question, L equal to between 1 and 2 is 3 Henry when 3 and 4 short circuited. When 3 and 4 short circuited. Okay, so what will be the figure now? It is short circuited. It is short circuited. L1 minus M. L1 is 4, right? 4 minus M. M is given, right? Is there any M in the question? No. Okay, simply L1 minus M. So it will be 4 minus M, correct? 4 minus m, and this also m, right? This also m, and it is L2 minus m. L2 is given as what? L2 is given as 2. So L2 minus m will be simply 2 minus m, 2 minus m, and the effective value by looking from this side will be what? L equivalent between 1 and 2 is 3 Henry. So this will be 3 Henry. So 3 Henry will be the answer if you short circuit the 3 and 4, but 3 Henry will be the answer if you short circuit the terminal 3 and 4. And now looking into the circuit, you may be surprised that this 4 minus m, the effective inductance or the effective inductance will be, that is 3 Henry is nothing but 3 is equal to 4 minus m plus m parallel to 2 minus m. Is it clear? I know you may be confused. I will explain. The 3 will be equal to, 3 is nothing but the 3 Henry, overall inductance 3 Henry. If it is short circuited means, see, these and these will be form a 2 parallel path, right? This one parallel path, another this parallel path, because the common ends are connected together, right? The common ends here, no, both common ends are connected, same. That's why it is 2 in parallel. It is in series with this 4 minus m bus. So the effective combination will be equal to what? 3 Henry. Effective combination will be equal to what? 3 Henry. Clear? So our aim is to find m from here. Let's check. Let's see that. It is nothing but 4 minus m plus, and you may have one more doubt that, sir, can we do the operations in resistor like inductor? If you want to do parallel or series conversions, the resistance or the inductor should first convert it into inductive reactance, right? You may have a question like this. Of course, but what is XL? L into omega. If omega is common, that means the supply is same for both the inductances, then you can have the same parallel connection equation like resistance in the case of inductance also. You can use that also. You can use capacitance case also. If two capacitors are in parallel connection, you don't want to go for XC1 and XC2 because omega is common there. So you can directly go for the parallel equation. So like that, in inductance also we can use the same series or parallel equation like resistors. We don't want to convert it as inductance into inductive reactance. There is no need. Because if you convert this inductance into inductive reactance means if you are going to simply multiply with omega is there, right? Omega is there, right? You will do that. Okay. So this can be write like, see, I can write like XL. No, it is simply 3. So it will be equal to 4 minus 3 will be equal to 4 minus m plus m parallel to 2 minus m, means the resultant will be m into 2 minus m divided by m plus 2 minus m. M plus 2 minus m. This m and n can cancel. So it will be like, see, 4 minus m plus 2m minus m square. Okay, and 3 will be equal to, what is that? Minus m square plus m plus 4, correct? So m square plus m minus m square plus m plus 4 equal to 3, correct? So can I rub this? Yes, it is 2 right here. 2m minus m square by 2, right? Yes. So it will be like this, 2. Okay. So it will be 3 will be equal to 4 minus m plus m, right? Plus m minus m square by 2, correct? If you multiply both sides with 2, it will become 6 equal to 8 minus m and plus m got cancelled, right? Minus m and plus m got cancelled, right? So it will become 8 minus m square, right? So it will become m square equal to minus m square equal to minus 2, or m square equal to 2, or m will be equal to plus or minus root 2. M is equal to plus or minus root 2. Did you get this? Did you get this? Did you get this? M is equal to what? What? Plus or minus root 2. And we have to find the coefficient of coupling, right? For k equal to, or simply m is equal to, what is the equation? M is equal to k root of L1 L2, or we have k is equal to m divided by root of L1 L2, correct? So it will be equal to m. What is m here? What is m here? You got plus or minus root 2, right? So I took plus root 2 divided by root of L1. What is L1 here? 4 Henry, right? So 4 into, what is L2 here? L2 is already given in the question, that's 2 Henry. So it will become root 2 divided by root 8, or simply root 2 divided by root 2 into root 4. So it will be 1 by 2. So simply k equal to 0.5. Superb question is this. Super question is that. It's a superb question. It's a superb question. Let's check the answer. K is equal to 0.5. Correct. K is equal to 0.5. Did you get that? Did you get that? Did you get that? Okay. Is there any doubt? Is there any doubt in the question? You simply arrange the equation. You simply apply some conditions. That is already in the question, right? That you apply simply, you will get the answer. Focus on the questions better. Focus on the questions, my dears. Okay. Focus on the questions. Focus on the questions. Okay, is there any doubt in the last session? Okay, can we do one more interesting problems? Can we do one more interesting problem? Okay, write a question. Question is, find k for resonance. Find k at resonance. Write the question. Write the question. Write the question. Write the question. How can we proceed with? How can we proceed with? How can we proceed with? In this question, the parameters are in direct XL or XC format. That means it is directly in what? L omega format, right? L omega format. But we don't have the equation for XL or XC, right? We simply have the equation for what? L1 or L2, right? L equation are in our hands. That means this is a, see, consider the case of inductance here, only inductance, focus on only inductances. If two inductance are series here, right, series, I know that series, but it is series aiding or series opposing. In this question it is in series opposing, right, because here is the dot sign and here is the dot sign. So suppose the current is sending from here, the two currents will be in opposite direction. That means this is a series opposing circuit, right? Opposing circuit. So L equivalent will be equal to, what is that? L1 plus L2 minus 2L. Am I correct? L1 plus L2 minus 2L. Am I correct or not? L equivalent will be equal to what? L1 plus L2 minus 2M. Correct. Suppose I am multiplying this equation with omega, right? It will become omega into L equivalent equal to omega into L1 plus omega into L2 minus 2M into omega. Correct or wrong, beta? Correct or wrong? Correct or wrong? Okay. And it will become again, what is omega into L equivalent? Let I am representing XL equivalent. Omega into L, what is omega into L? It is XL, right? So XL equivalent equal to XL1 plus XL2 minus 2 into, what is M here? M is nothing but K root of L1 L2, because we need the equation for K. So where we can apply K is simply in terms of M, right? Then only we can apply K. So that equation only contains K, right? That's why we replace this M with K root L1 L2. Okay, is there any doubt? No. And again I am going to rearrange the equation like XL1 plus XL2 minus 2K into L1 into omega into L2 into omega. Can I do this? Can I do this? That means I inserted this omega inside the root. I put this omega inside the root means it will be omega square. Omega square I split again, one for this L1 and another for this L2. Bas. So it will become XL1 plus XL2 minus 2K into root of, what is L1 omega? It is nothing but XL1. What is L2 omega? It is nothing but XL2. Okay. And what is XL1? It is nothing but J8. So J8 means it is J into XL, correct? J8 means that J into XL. So XL is simply 8. Here also XL2, J into 8 means it's again XL is equal to 8 only, right? J into XL, right? Inductive reactance, I mean in terms of inductance and what? Imaginary, right? Imaginary concept. It will be R minus or plus Jx, right? So minus or plus J we don't want, simply we need XL plus. And it is given in the capacitive circuit, right? In capacitive RLCs, it is a RLC circuit. When the resonance happens, when that resonance happens means when XL equal to XC. So when XL equal to XC only that resonance will happen, okay? So XL equivalent will be equal to, XL equivalent is nothing but what? XL equivalent is at what when a resonance happens, XL will be equal to what? XC, right? So XC is what? XC is what? 12. So XL equivalent will be equal to XC at a resonance, correct? That means this XL equivalent can be replaced with XC equivalent or simply XC also. XC also, because XL equal to XC only when the resonance happens, right? So it will become 12, right? XC is what here? 12, correct? 12, no? 12. So is 12 equal to XL1 is nothing but 8 plus XL2 is also 8 minus 2K into root of XL1 is again 8, XL2 again it's 8. So it will become 12 equal to 16 minus 2k into 8, or 12 equal to 16 minus 16k, or minus 4 equal to minus 16k, right? Minus 4 equal to minus 16k, or k is equal to 1 by 4. K is equal to 1 by 4. That is the answer. Very, very interesting and outstanding question actually. This is very standard question. This is very difficult question. I know that. This is very difficult question, but you have to practice up to this level, right? You have to practice up to this level. You have to do this again and again. When you are revising your subject, you have to do this again and again. Then only when so many things you can apply here, right? So many things you are simultaneously applying here. Excel, concept of Excel and resonance. Excel is equal to XC, only resonance will happen. That is why this is a very high level problem. This is very, very high level problem. I know that. Very high level problem. In SSC JEE, RRB JEE, these type of question you can't expect there. So that may be very, very easy question you can expect there. Simply L1 plus L2 plus 2m or minus 2m, or that equation itself, no, series and parallel equation itself, that also you may expect. L1 L2 minus m divided by minus m square divided by L1 plus L2 minus or plus 2m, no, that equation also you can expect. But not this level of question you can't expect, but we have to prepare up to this level, right? Then only that's it. Below problems, right? Below range problems will be very, very easier for us. That is the main purpose of doing this type of question in my classes. Okay, this is very important problems. Is it clear, beta? Is it clear, my dears? Okay, so that's all about today's session. So let's meet a new topic on tomorrow. Okay, so thank you so much.